Hello everyone, this is John Wen. Today is February 3rd, 2021. In today's video, I'm going to go through the research updates since the past week. So as you can see, I'm still working on the deep learning workflow in DataView system. And from the past weeks, I was able to construct a new network as a task in the DataView 2.2. And here is a screenshot of the workflow which contains the new network task. And the whole workflow will have a one input file which specifies the layers we want in the new network. Many thanks to Dr. Lu's advice, I was working on the new network visualization in the past week, and it has been completed right now. As you can see, here is a screenshot of the visualization of one of the new network. If we take a look at the Eclipse, and this is a file I was working on, which is a new network visualization.java. This one is pretty similar to workflow visualization. Instead of visualize by workflow and edges, we have to construct the layers by layers and neurons by neurons to connect them together. So this is the idea. So if we take a look at the simple neural network workflow, and here we have one input files, which is network specs.txt. And here we can test two different neural network structures. For the first one, it has very simple 4 layers. For the second one, it has more layers, which has 3 linear layers and 2 ReLU layers. So firstly, let's test the first one. So if we run the test.java, and we will be able to see that soon. So you can see here is the first one, which has, compared to the data, which has 4 layers. And here we have the 0 to 5. That means 0 means a linear layer. So you can see the linear layers has 2 input neurons and 5 output neurons. And then we have the 1 specify the ReLU layers. So we have all ReLU neurons connect to the output of linear layers. And then we have another linear layer which has a 5 input neuron and 1 output neuron. Lastly, we have 1 sigmoid neurons. So this is one of example, and we can close this one, and then we can change the input files to the second one. This is netspecs.txt one. So if we run the test.java again, and we will be able to see the new network we constructed. So here is a 1. So if we compare with a file, here is a new network specification 1, and here is a picture. So here we have, again, we have the 0 stands for linear layer, so we have 2 input neuron, 5 output neuron, and then we have a ReLU layer, and then we have another linear layer which has 5 input neuron and 3 output neuron, and then we have another ReLU layer, and finally we have linear layer with a 3 input neuron and 1 output neuron. Then we have the sigmoid neuron as the last layer. So this is a work I was working on. Come back to the slides. I still working on another item, which is working on to feed the whole workflow with a CSV file as input data. Right now, the data was randomly generated in the CUDA program or CUDA code, but finally, I think it is necessary to feed the whole workflow with the input file, because we may want to pass input data from the Java to the CUDA, because we want to distribute the input data to multiple GPUs VMs in one day. So I think that's the plan. So currently I'm working on this one. And many thanks to Dr. Lu. He reminded us about 2021 SCC committee, which is IEEE conference. I think this is very good opportunity to submit another paper. So I think about that, and here is one paper proposal. So I think this might be a good idea, which is distributed cross validations on neural network in DataView CUDA workflow on Amazon GPU clouds. So I'm targeting to run a 5-fold cross-validation on a binary classification problem, which is quite similar to what I have right now. And here is the implementation plan. Firstly, I will create and generate input data.csv file, which has been done. So I think I will make it more complicated. And here is a picture of the input files or input data. What does it look like? So in the coordinates, we split into 8 parts, and for the blue parts or area with blue points, we specify it as a category 1, and for the area with red points, we specify as a category 0. So as you can see, this kind of classification is highly unlinear, so we cannot do in a kind of normal or traditional model. So this is very good for the neural network or deep neural network. This can be something we can do from the start. And the 5 cross validation is good for our project because it can be parallelized, because we can send different folds to different virtual machine and they can run in parallel instead of serialize them in one virtual machine or one computer. It can be highly efficient if we can do that in parallel. So basically, the cross-validation is helping us to find the best model we want. Maybe we can feed 2 of the model or 3 of the model into multiple VMs and to let them to run the k-fold cross-validation together. And finally, we will get the result from those machines, and then we can choose the best item or best model and train the neural network again, and finally we get a result. So this is the first item to get input data.csv, which has been completed. I work on a C++ code to generate the data, which is in the CSV file like this. So you can see which is corresponding to the graph I was showing just now. We have 8 partitions in the coordinates, and they stand for 2 kind of classification, either 0 or 1. So we can use this data to feed into the Java project. But I think the most important thing is to parse those data from the GNI to the CUDA code and to let the CUDA code successfully accept those data. So I think that may take some time, but I will work on that as soon as possible. And later, I think I will work on to provision the GPU VMs from the AWS and to configure the CUDA environment on those GPUs. So the next step is to send data and to execute the CUDA code on the GPU VMs. So I think this is a implementation plan, and hopefully this will be still be enough time to make all the things happen. I think I will work on that, and hopefully we can get a good result very soon, and then we can construct a paper and submit to the 2021 SEC committee. So I think that's pretty much from today's updates. Thank you so much for your time. Hope you enjoy. Until next time, happy coding.